So, all right. Objective 2, we want to decompose P over Q, where Q has now a repeated linear factor. So what we just saw was non-repeated linear factors. Now we have repeated linear factors. So this is going to be x minus 2 times x minus 2, or x minus 2 squared, something like that. So for case 2, where Q has repeated linear factors, if the polynomial Q has a repeated linear factor, say x minus a to the power of n, where n is greater than or equal to 2, an integer, then in the partial fraction decomposition of P over Q, we allow for the terms a1 over x minus a plus a2 divided by x minus a squared plus all the way up until you get to an divided by x minus a to the power of n, where the numbers a sub 1, a sub 2 to a sub n are going to be determined. So remember, you can write them as a sub 1, a sub 2. You could also write them as just a, b, until you get to the end. So all right, let's go ahead and do an example. So example 2, we want to find the partial fraction decomposition of x plus 2 divided by x to the power of 3 minus 2x squared plus x. So first things first, you always want to factor the denominator. So first, we factor the denominator. So we have x to the power of 3 minus 2x squared plus x. We obviously see there is an x in each term, so we can easily rewrite this first as just x times x squared minus 2x plus 1. And what this leaves us with is x times x minus 1 squared. So we have x times x minus 1 squared as our factored denominator. Now, we essentially have two different sets here. We can think of them first individually as x and x minus 1 squared. If we think of them individually, this allows us to use case 1 to just state a over x. So let's write that out. By case 1, a over x is in the decomposition. This is because the first thing we're doing is just analyzing the two separate factors, x and x minus 1 squared. So because of that, a over x is included in the decomposition. Then, by case 2, we now only consider x minus 1 squared, which is x minus 1 times x minus 1, which tells us now that b over x minus 1 plus c, plus c over x minus 1 squared is also in the decomposition. So we kind of had two things going on. So first, we had to acknowledge that there was an additional factor, not including the repeated linear factor. And by that means we had to use case 1 to kind of separate them. From there, we went on to reanalyze x minus 1 squared and then separated that once again using case 2. So we can write that out as well. So we can say like case 1, and then this was case 2. So this now means as our partial fraction decomposition that we have x plus 2 over x to the power of 3 minus 2x squared plus x is going to be equal to a over x plus b over x minus 1 plus c over x minus 1 squared. So we need to solve for, in this case, a, b, and c. So to get rid of all of our denominators, we want to multiply each term by x times x minus 1 squared, which we also know is equal to x to the power of 3 minus 2x squared plus x. So when we do that, this leaves us with x plus 2 is equal to a times x minus 1 squared plus bx times x minus 1 plus cx. So we get these values because we've multiplied each separate term by x times x minus 1 squared, and this is what now we're left with. So like we said before, we can either set up an identity, or we can just clear out fractions by strategically picking values of x, which is going to be easier. So let's go ahead and do that. So to clear out 2 of our terms right away is that we can let x be equal to 0. If we let x be equal to 0, b is being multiplied by x and c is being multiplied by x. So that means that b and c both go away, and all we're left with is a. So if we let x be equal to 0, to get rid of the b and c terms, then when we plug in 0, we get 0 plus 2 is equal to a times 0 minus 1 squared plus 0 plus 0. So we won't include them. This simplifies down to 2 is equal to negative 1 squared is just 1. So 2 is equal to a. So we went ahead and we found our value of a. Now we want to go ahead and try to find or strategically pick values of x that would make our a and our b terms go away. So in this case, we're going to let x equal 1. Because if x equals 1, then our x minus 1 squared and our x minus 1 will cancel each other out as well and get rid of our a and b terms. So we let x equal 1 to get rid of the a and b terms. Then what we're left with is 1 plus 2 is equal to c times 1, which just simplifies to c is equal to 3. So we solve for a and we solve for c in this case. Now, to solve for a term of b, we can let x be equal to anything. We just can't let it be equal to 0 or 1 in order to actually solve for b. So we're going to let x just be equal to 2. We can let x equal to 2 or any number, not 0 or 1. To find b. So in this case, if we let x be equal to 2, this gives us 2 plus 2 is equal to a, which we know is 2 times 2 minus 1 squared plus b times 2 times 2 minus 1 plus c, which is 3 times 2. So simplifying this down, 2 minus 1 is just going to be 1, so that's 2 times 1 squared, which is 2. Plus b times 2 is 2b times 2 minus 1, which is just 1, so plus 2b. Plus 3 times 2, which is 6. So 2 plus 6 is going to be 8, so this really just looks like 8, or 4 is equal to 8 plus 2b, which we can subtract 8 from both sides. We get 2b is equal to negative 4. And solving for b, we get b is equal to negative 2. So all right, now that we found our values of a, b, and c, we can write them back into our original equation that we wrote out for our partial fraction decomposition and arrive to our answer. So we say thus, a is equal to 2, b is equal to negative 2, and c is equal to 3 to give us our partial fraction decomposition of x plus 2 divided by x to the power of 3 minus 2x squared plus x is equal to 2 over x plus negative 2 over x minus 1 plus 3 over x minus 1 squared. And this would be our final answer. And once again, if you'd like to check your answer, you would just add up these fractions as you normally would. And that concludes another very long problem. As we can see, partial fraction decompositions can end up being quite lengthy, especially with ones with case 1 and case 2.